1 2 1 2 1 2 1 2 1 2. Woo!
Hello guys, and welcome back to this one. So this time around we are going to be looking straight into the graphical illustration. I have with me here a left heap and a right heap. One on the left, which is a max heap, and one on the right, which is a mini heap. Now we are going to be looking at the solutions. Starting from here. So we have the initial count at 0, and we have our median with no value. Now we see 10 coming to the fold. From our code, it basically tells us, what do you know what? If this guy is empty, if the left guy is empty, first update it with -10, right? So that's the first bit. So that one goes, and then we go ahead to increase the count to 1. So I won't be increasing the count every time because of the reiteration. But yeah, we increase the count to 1, we go through the system, see that we just have one value and print out the median of 10. So that's a no-brainer. Now we bring in the second value, we say this is 2. So we check, if we had 10 and 2 here, what would have been here would be 2. So a max heap is trying to turn that around and return us the minimum. It's going to still return us the minimum value, but the point is that it's going to return the minimum value, but it's going to be an illusion of the minimum value. The minus is going to make it this thing. So it's going to still return minimum value, which is -10, which is lesser than -2. So that when we now want to pop, we pop 10. So when it does the rearrangement, it's still going to return 10. So what do? We go ahead to just pick out 10, and now we are popping from here. We pop from here, we take out 10 and make it 2 again, and then push 10 into this bit. Push 10, not -10. The mini heap doesn't need help this time around. Now, what happens next? 3 comes into the fold. Now, 3 compares and sees if it is less than 2. It is not less than 2. So what do? We push 3 into the right heap, which is 3 over here. Now, what happens here? 3 becomes 10 because the heap immediately rearranges itself using the log n time complexity. We'll get to see that when we get to complexity. Now we have this space. Now we have 15. So sorry, I'm not even printing out. Now for 2, after solving the bits, we had 2 and 10. So we'll go down our third build where we will see, oh, these two guys are equal. So we just pop the left and the right. So at that instance, before we added 3, we had 2 and 10. So this would give us what? Give us 6, right? Now 3 is in the fold. So we now have -2, 3, and 10. So what do? We said if left is greater than right, obviously we return, but if right is greater, so right is the guy we are going to pop it now. So right is greater at this point because right at this point is 2, and count of right left at this point is what? 1. So at the end of the day, boom, 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 we hit 3. Now 15 comes into the fold. We check, is 15 less than 2? So 15 is not less than 2. So what do? We put 15 into this space, right? But one thing has happened. This count size has increased to 3, making it 2 times greater than this. So we have to rearrange this guy and pop something into this guy. So what do? We pop from our code base. What do? We check that right is greater than left plus 1. So we do what? We pop from the right 3. We pop 3 from here, and we push that into this place. So we have -3 over here. But -3 is lesser. So the heap rearranges itself and gives us this, right? So 3 goes away here, 10 comes into this bit, and boom, this is how our heap looks now. We solve the mean of these two guys, and we have our value at 6.5, right? So the last guy now is 15. 15 comes again, compares itself to 3. 15 is less than 3. It's greater than 3. So we add that here. Now once we add that here, this becomes what? This remains 3, but it's not 2 times. It's not greater than this by more than 1. So we remain as we are. But then again, we don't then have an even, what's it called? We don't have an even left and right side. So the median cannot be the solution between these two guys. We don't have a greater left side. So the solution, the median cannot be this right guy. So, but we have a greater right side, meaning that this is our answer for the median. So we have 10. So we see immediately that this guy solves the problem smoother. Like he's just basically interacting with the middle. This like all the heap, this is the middle, this all the heap, this is the middle. And because of this system, it's able to just interact with the middle directly. No need sorting the whole list first just to get where the middle is and then do what we did with the function sort on median, right? And basically we have our solution printed out clearly over here. So we see that solution clearly over here. So yeah, that's it for graphical illustration. Next up, we're going to then look at the debugger tool to see how the solution comes to life in real time. Muchas gracias. See you on the next one. Bye.